this is our second lesson video for Chapter 1 for AP Chem. And in this video, we are just going to cover Section 1.5. Because once we get to units of measurement and significant figures and converting, I think we all know, some of y'all had a little bit of trouble with that in Honors Chem. So we need to get that down, get it together, because that should be second nature to you by the time you're done with this class. Well, preferably before you take the AP exam. So we're going to talk about units of measurement. So quantitative properties are associated with numbers, and the SI units are the preferred units for science. However, you know that sometimes we don't use those units. Okay, so for time it's seconds, for length is meters, mass is kilograms, electric current is the ampere, temperature is Kelvin, amount of substance is mole, and luminous intensity is candela. And so y'all know that sometimes we don't use kilograms, we might use grams. Sometimes we don't use Kelvin, we might use Celsius. But these are the base units. So you need to make sure that you remember how to convert between units with different prefixes using this chart. So again, this chart for some of you was a nightmare. You need to make it not a nightmare anymore. There should be no issue with you easily doing a conversion when you have the chart. Okay, it's one thing if I made you memorize it, I didn't. Okay, so make sure you can easily do conversions. We're going to be doing those in these videos. So it says, what is the name of the unit that equals 10 to the negative 9 grams? Well, if you look at that chart that I just showed you, you'll see that 10 to the negative 9 is nano. So, I don't know why I'm writing it when I can just click. So 10 to the negative 9 grams would be a nanogram. I'll wait and click at the end because I think they all come up together. I don't remember what I did. All right, so part B is 10 to the negative 6 seconds. So if you look, 10 to the negative 6 is micro, so it will be microsecond. And then part C is 10 to the negative 3 meters. Well, if you look, 10 to the negative 3 is milli, so it would be millimeter. Okay, so we have nanogram, microsecond, millimeter. Okay, and again, that all comes from right here. So see, you can see 10 to the negative 9 is nano, so that's where I got nanogram. All right, so it says, which of the following weights would you expect to be suitable for weighing on an ordinary bathroom scale? All right, so these we're going to have to do a bunch of conversions. So hopefully you have an SI prefixes sheet out. If you don't, maybe pause the video and get one out unless you have it memorized. All right, so I already got all my mine worked out so you don't have to watch me use a calculator. All right, so what I'm going to do is change all of them to kilograms because a bathroom scale is meant to measure a human. And so, of course, our mass is normally in kilograms or pounds, of course, but we don't use pounds in science. All right, so I have milligrams right here. So I'm going to start with my 2.0 times 10 to the 7 milligrams. We are not going to harp on the golden rule because at this point you should know how to do this kind of stuff. Okay, so I'm going to go through this quickly. If you're struggling with this, you need to go all the way back to Honors Chemistry Chapter 3 videos, and that's where I'll teach this super slowly. But yeah, if you're in AP, this should not be hard for you at all. All right, so we have 1 milligram is 10 to the negative 3 grams because we follow golden rule and cancel. And now we're trying to get to kilograms. So I say 1 kilogram is 10 to the 3 grams. And grams cancel. And so just a friendly reminder of how you solve these. We multiply the top, divide by the bottom. Okay, so for this one, I ended up getting 20 kilograms. All right, so let's look at part B. So part B, they gave me 2,500 micrograms. Okay, so I need to change that to kilograms. So I can say, okay, well, 1 microgram is 10 to the negative 6 grams. And then I can say 1 kilogram is 10 to the 3 grams. So when I multiply and divide, for that one, I got 2.5 times 10 to the negative 6 kilograms. Okay, that was for part B. Part C is already in kilograms for me. So let me move on to part D. So part D is 4 times 10 to the 6 centigrams. So I do 1 centigram is 10 to the negative 2 grams. And of course, 1 kilogram is 10 to the 3 grams. And so y'all, what I want you to notice is how quickly I'm doing this. You might not be able to do it quite this quickly, but you do need to get to where something like this isn't going to take you 20 minutes. On the AP exam, if you had a question like this, you would not have 20 minutes to answer. All right, so I solved this one, and I get about 40 kilograms. And so then the very last one, we have 5.5 times 10 to the 8 decigrams. So I say, okay, well, 1 decigram is 10 to the negative 1 grams, and 1 kilogram is 10 to the 3 grams. And so then once I multiply, I get 55,000 kilograms. All right, so let's think. We're using a bathroom scale. Okay, 1 kilogram is 2.2 pounds. Okay, 1 kilogram is 2.2 pounds. So in other words, you're approximately going to double this if you want to think of it in terms of pounds. So would a bathroom scale be able to measure about 40 pounds? I would say so. So A works. Would a bathroom scale be measuring 2.5 times 10 to the negative 6 kilograms? No, that would be much too small for a bathroom scale. Okay, so it's definitely not B. For C, again, it's 0.0005 kilograms. Your bathroom scale is not that accurate, I promise. And then for part D, we get about 40 kilograms. Well, would it make sense that your scale would measure about 80 pounds? Yes, it would. And then for part E, we're talking about 55,000 kilograms. Do you think your bathroom scale can measure that? Most likely no. Now, I will tell you on this one, I have that it could possibly be 2 answers, but if this was on the AP exam, obviously you would only have 1 answer. So if I was stuck picking between 20 kilograms and 40, I would just think, okay, which one's closer to a human's actual weight? So like I said, this is going to be about 40 pounds versus about 80 pounds. So a bathroom scale would be more likely suitable for this. But we all know a bathroom scale can measure about this much too. So that's why I went ahead and circled A and D for that one. All right, so like I said, y'all, this should not have blown your mind. Like if you're looking at this and you're in utter confusion, that's a big problem for this class. Okay, so like I said, I put A and D because that was about 20 and 40 kilograms, both of which could be measured with the bathroom scale. So the next one, it says how many picometers are in 1 meter? Okay, well, 1 meter is 10 to the 12 picometers. Okay, so y'all, when we're using our chart, normally we say 1 of the prefix unit is 10 to the x base unit. So like we would normally say 1 picometer is 10 to the negative 12 meters. Well, if you want to flip your conversion factor, you're just going to change your power to positive. So, or you can say 1 meter is 10 to the 12 picometers. All right, it says express 6 times 10 to the 3 meters using a metric prefix to replace the power of 10. So what they're saying is we don't want to have to use the times 10 to the 3. Well, if you look at your SI prefixes chart, the power for 10 to the 3rd is kilo. So instead we could say 6 kilometers instead of 6 times 10 to the 3 meters. All right, part C says use exponential notation to express 4.22 milligrams in grams. Okay, well, 4.22 milligrams, we can say 1 milligram is 10 to the negative 3 grams. And so then once we multiply that out, we are going to get 4.22 times 10 to the negative 3 grams. All right, and then the bottom one, it says use decimal notation to express 4.22 milligrams in grams. Okay, well here we use scientific notation, which as you can see is sometimes called exponential notation because we're using an exponent. So scientific and exponential notation are the same. Well, this one wants us to do it in decimal. So it's still going to be the same number, I just need to take it out of scientific notation. So it'd be 0.00422 grams. Just like that. Okay, now hopefully scientific notation is super easy for you. Alright, so let's move on. And again, y'all, please know that all of this should just be so incredibly easy that hopefully you're wondering why I even wasted time making this video. Alright, so temperature. Temperature is the measure of the average kinetic energy of the particles in a substance. So remember, temperature is not the basic definition, how hot or cold something is. It's the average kinetic energy of the particles. Absolute zero, which was 0 on the Kelvin scale, 0 Kelvin, is the temperature at which the motion of particles stops. So that's why Kelvin has no negatives. The size of a degree in Celsius is the same as the size of a degree in Kelvin. However, a degree in Fahrenheit is smaller. So what I mean by that is on the Celsius scale, there are 100 degrees in between when water freezes and boils, because it's 0 and 100. So 100 minus 0 is 100. So there's 100 degrees here. For Kelvin, it's the same difference. Water freezes at 273 and boils at 373. So there's still a 100 degree difference. So a degree in Celsius and a degree in Kelvin are the same size. However, for water on Fahrenheit, it freezes at 32, but yet it boils at 212. So that's actually 180 degrees. So that's why we say a degree in Fahrenheit is smaller. Okay, and then we use this formula frequently to get from Celsius to Kelvin. We add 273. We barely ever use these because we don't use Fahrenheit very often. But just remember, if you do need this formula, you do Fahrenheit minus 32 first, then times the 5/9. To use this formula, you multiply Celsius by 9/5 first, and then add the 32. So make sure you follow your orders of operation. Alright, so it says, a weather forecaster predicts the temperature will reach 31 degrees Celsius. What is this temperature in Kelvin? So, first thing I have to do is say, okay, well, Kelvin is Celsius plus 273. So I just plug in. 31 plus 273 is 304 Kelvin. That's all I have to do for that one. Then it says, what is this temperature in Fahrenheit? Now, like I said, you probably won't need to use Fahrenheit very much just because we don't use it in science very often at all because it's a ridiculous unit of measure. However, we're going from Celsius to Fahrenheit. So sometimes you'll have trouble figuring out which one to use. So the one you're looking for should be alone. So see, this formula is set up to solve for Celsius. This formula is set up to solve for Fahrenheit. So Fahrenheit is 9/5 times Celsius plus 32. Okay, so that's the formula I would use. So Fahrenheit is 9/5 times degrees Celsius plus 32. So remember, that means I'm going to multiply the fraction and the degrees Celsius first, then add the 32. So I do 9/5 times 31 plus 32. And once I do that, I end up getting about 87.8 degrees Fahrenheit. So the other thing I just want to do a friendly reminder of is, remember, Celsius and Fahrenheit have the degree sign. Kelvin does not. It's just a capital K. Alright, so hopefully that wasn't too bad. It shouldn't have been. Alright, so next it says ethylene glycol, the major ingredient in antifreeze, freezes at negative 11.5 degrees Celsius. What is the freezing point in Kelvin? Well, again, Kelvin is degrees Celsius plus 273. So I just do negative 11.5 plus 273. And I end up getting 261.5 Kelvin. Alright, and down here we're going to Fahrenheit again. So Fahrenheit is 9/5 times my degrees Celsius plus 32. So I just plug in. So 9/5 times my negative 11.5 plus 32. And that ends up giving me about 11.3 degrees Fahrenheit. Okay, so again, it's just plugging into formulas. That should be super easy. Okay, having a formula, I mean, that Like, you practically have the answer if you have a formula to plug into. Alright, so next we are going to talk about density a little bit. So we've already learned this formula for density. So density is the amount of mass in a unit volume of a substance. Its formula is density equals mass over volume. The SI unit for energy is the joule. So a joule is just a derived unit. It's actually a kilogram, sorry, a kilogram times meters squared per second squared. Sorry again, oh my gosh, I hope this doesn't continue because I'm going to have to start the video over. So a calorie is the amount of energy required to raise 1 gram of water 1 degree Celsius. So 1 calorie equals 4.184 joules. We learned that back in Honors Chem. And a nutritional calorie, or a calorie with a capital C, is actually just a kilocalorie. So 1 nutritional, or 1 capital calorie, equals 1,000 calories. So make sure that you notice the difference in, is it lowercase or is it uppercase, because that determines whether it's a kilocalorie or not. So it says, calculate the density of mercury if 1 times 10 to the 2 grams occupies a volume of 7.36 centimeters cubed. Okay, so I'm looking for density. So my D is my question mark. I have this many grams, so there's my mass. And it occupies this volume, so there's my volume. So since I'm solving for density, we know density equals mass over volume. I don't even need to rearrange the formula. I can just plug in. So my mass is 1 times 10 to the 2 grams. My volume is 7.36 centimeters cubed. So I just divide, and when I divided, I got 13.6. And then a gram and a centimeter cubed is not going to cancel out. So I have grams per centimeter cubed. Density will always have double units, like grams per milliliter, kilograms per liter, grams per centimeter cubed, something like that. All right, so part B. It says calculate the volume, so this time I'm looking for V, of 65 grams, so there's my mass, of liquid methanol if its density is 0.791 grams per milliliter. Okay, so this time I'm looking for volume, so I am going to have to rearrange my formula. And so y'all, rearranging a formula quickly is an important skill to have. Okay, we're solving for volume. When you solve for something, you don't want it to be in the denominator. You want it to be in the numerator. So what I'm going to do first is multiply both sides by volumes to see how it'll cancel, just so I can get it into the numerator. So see, now volume is in the numerator. So then to move density, I can divide it to the other side. So volume is mass over density. Many of you have trouble solving for something in the denominator. So once I have that, I just plug in 65 grams divided by my density, which is 0.791 grams per milliliter. So I do my dividing. I get 82.2. And then if you look, my grams cancel and I'm left with milliliters as my answer. Just like that. Now if you are lucky enough to get a question this easy on the AP exam, you better thank your lucky stars, because this is way too easy to show up on there. But hey, fingers crossed. Fingers crossed we get an easy exam this year. So part C, it says what is the mass in grams? So this time I'm solving for mass. Of a cube of gold, the density is 19.32 grams per centimeter cubed. So there's my density. If the length of the cube is 2 centimeters. So I'm going to have to use that to get my volume. Now, a lot of you will automatically just pull that 2 and say, oh, well, that's the volume. But y'all, it's a cube. It says the length is 2 centimeters. It doesn't say volume. So what's volume? Well, you already know. Volume is length times width times height. So the length is 2 centimeters. Well, what's the width? Well, it's a cube. All the sides are equal. So that means the width is 2 centimeters. And what's the height? 2 centimeters. So 2 times 2 times 2 is 8 centimeters cubed. So that's going to be my volume. So see, this is one that would be very easy for you to miss because a lot of you would plug in 2 for volume. Okay, and you don't need to do that. So density equals mass over volume. This time I'm solving for mass. So how do I get volume to the other side? I multiply. So then I just plug in. So my volume is 8 centimeters cubed. That's another way to know this isn't the volume. Volume always has a cube unit, or could be milliliters or liters, or something liters based. Just centimeters or something like that is just a distance. So I do the volume times the density, 19.32 grams per centimeter cubed. And so this time I just multiply. So I got 154.6. Those centimeters cubed cancel, and I'm left with grams. Okay, so this was showing all 3 ways you can use the density formula. All right, so let's move on and try a few more. And at any point in time, y'all, if you want to pause the video, try it on your own. That would probably be helpful. Remember, you got to be able to do these, not me. All right, so again, pause whenever you want so that way you can try these, but I'm just going to go ahead and keep on going. So it says calculate the density. So we're looking for density of a 374.5 grams, there's my mass, sample of copper if it has a volume of 41.8 centimeters cubed. So there's my volume. So for this one, again, I'm just solving for density, so I don't even need to rearrange. Density is mass over volume, and then I just plug in. So my mass is 374.5 grams, and my volume is 41.8 centimeters cubed. So I just divide, which hopefully is what you did, and I got 8.96. And then remember, a gram and centimeter cubed does not cancel, so I need both units. All right, so hopefully you got that one right. If not, again, you really need to question your life at this point, because this class is going to kill you. All right, part B, it says a student needs 15 grams. So there's my mass. Ooh, I don't have a lot of room, I'm just going to write underneath it. Of ethanol for an experiment. If the density of ethanol is 0.789 grams per milliliter, how many milliliters of ethanol are needed? So I'm looking for volume. Okay, so again, I'm going to show you how to rearrange for volume one more time. Although this should become second nature to you. Okay, so I'm solving for something in the denominator. So the first step is get it to the numerator. Once I have it in the numerator, then I can divide both sides by density. So now volume is in the numerator, and I can see it's mass over density. Once I get to that point, I can just plug in. So my mass is 15 grams, and my density is 0.789 grams per milliliter. So then I just divide, so I get 19.01. My grams cancel, I'm left with milliliters. Just like that. So hopefully you got that one right. All right, so our last one, it says, what is the mass? Oh, this should say in grams, not if grams. So I'm going to put mass question mark. What is the mass in grams of 25 milliliters, so that's my volume, of mercury if the density is 13.6 grams per milliliter? So there's my density. Okay, so this time I'm just solving for mass. Super easy. Remember, whenever you get lucky enough to get a question with a formula to plug into, that is the best. All right, so mass is volume times density. So then I just plug in. So my volume is 25 milliliters. My density is 13.6 grams per milliliter. So I just multiply. So I got 340. And then my milliliters cancel, and I'm left with grams. Just like that. So hopefully you got all 3 of these right. You easily should have gotten all 3 of these right. Okay, so let's move on. And don't worry, y'all, the later videos on stuff that you shouldn't have already learned in Honors Chem, I will obviously do a better job of explaining everything. This is just review. All right, so it says, a standard propane, which is C3H8 tank, used in an outdoor grill holds approximately 9 kilograms of propane. When the grill is operating, propane reacts with oxygen to form carbon dioxide and water. for every gram of propane that reacts with oxygen in this way, 46 kilojoules of energy is released as heat. So it says how much energy is released if the entire contents of the propane tank react with oxygen. Okay, so y'all, we have 9 kilograms of propane. Every 1 gram of propane is 46 kilojoules of energy. So we're trying to figure out how much energy if we burn the whole tank. Okay, so what do we start with? Well, we know the tank is 9 kilograms. We also know that 1 gram is 46 kilojoules. So what I need to do is get from kilograms to grams. So 1 kilogram is 10 to the 3 grams. So kilograms cancel. So see, now I got to grams. And then what I know is 1 gram of propane releases 46 kilojoules of energy. So see, now grams cancel. Since all 3 of my numbers are on top, I'm just going to multiply. And so I got 114,000 kilojoules. Just like that. Okay, so see y'all, things like this, where there is no actual formula and you're just using conversion factors, you have to use your units to work your way through it. Okay, a lot of you struggle if there's not a specific formula you plug into. But y'all, if you just follow the golden rule, figure out how to get to the unit they're asking for, then you got it. All right, part B, it says, as the propane reacts, does the potential energy stored in the chemical bonds increase or decrease? Okay, so for this one, we are doing what to the energy? We are releasing the energy. So where does that energy have to come from? Well, it has to come from the bonds. So if it's releasing all of this energy, that means the energy in the bonds is decreasing. So we would put decrease for that, because of course energy can't be created or destroyed through physical or chemical processes. All right, so hopefully that one wasn't bad. Again, you just got to learn how to work with the units. All right, so let's end with an awesome one about a milkshake. So it says a 12-ounce vanilla milkshake at a fast food restaurant contains 547 calories. Notice it's a capital C calorie. So that's a nutritional calorie, a kilocalorie. What quantity of energy is this in joules? So we know 1 calorie is 4.184 joules. However, this is a lowercase c calorie. We also know 1 capital C calorie is 1,000 calories. So once we know that, we can just start our problem. So we're starting with 547 capital C calories. So I can say, okay, well 1 calorie equals 1,000 calories. So the capital C calories are gone. And then I can say 1 calorie is 4.184 joules. And so that gets me to joules. So I just multiply across the top. And so I ended up getting 2,288,648 joules. And of course, you are more than welcome to put this in scientific notation if you prefer, and put about 2.3 times 10 to the 1, 2, 3, 4, 5, 6. 2.3 times 10 to 6 joules works fine too, especially once we start talking about significant figures. That's probably the better answer choice. All right, so hopefully, again, this is not new. It might be that you needed a refresher on it, but it should not have been new. All of this is stuff that we've done before. Okay, so again, for all of Chapter 1, we have learned all of this. I'm only making these videos as a refresher